Hello, good morning. Structure of acetylene. Acetylene is sp hybridization. We have already discussed about hybridization. In case of acetylene, the carbon-hydrogen bond and carbon-carbon bond. The carbon-hydrogen bond distance is 106 picometer and carbon-carbon bond 120 picometer. This is the orbital structure of acetylene, the sigma bond, and this is the pi orbitals. This is the pi bond. Physical properties of alkynes. Alkynes have similar physical properties to alkanes and alkenes. Lower alkynes up to 4 carbon atoms are gaseous, 5 to 13 carbon atoms liquid, while higher alkynes are solids. The boiling point and melting points increases with increase in the number of carbon atoms. Alkynes are sparingly soluble in polar solvents such as water, but are readily soluble in organic solvents such as benzene, ether, etc. Industrial sources of acetylene. Acetylene is produced industrially by the controlled high temperature partial oxidation of methane. Preparation of alkynes, dehydrohalogenation. D means removal of hydrogen, and halogenation. Genation means addition. Halogen is addition of alkali halides. When vinyl dihalides is treated with base, produces alkyne. In this example, alkene is added halogen and dihalide, and the halide is removed and produces alkyne. In case of propene is treated with bromine, it produces 1,2-dibromine. When added with KOH, 1-bromo-1-propene, and sodium amide produces propine. Vicinal dihalide converted into alkyne, geminal dihalide converted into alkyne. Mechanism. In case of dihalide, the bromine is attached in this carbon, so it is partially positively charged. In case of sodium amide, the amide are negative and it attracts the hydrogen. Similarly, another halide is attacked by sodium amide and produces alkyne. From vicinal dihalides, from the action of acetylides on alkyl halides, the mechanism is same. This is the methyl bromide. Bromide have partially negative charge and medium have partially positive charge. In sodium acetylide also have sodium have positive charge and carbon negative charge. So the negatively charged carbon attacks the positively charged of attacks methyl groups. So it produces the ethine, not butane, that is the alkyne. Preparation of alkyls from alkenes. Preparation of acetylene from calcium carbide, from cold reaction, iodoform, dehalogen of tetrahalide, reaction of alkynes, addition of hydrogen. In case of mechanism, platinum uh, have the hydrogen, oculated hydrogen. This oculated hydrogen acts as a catalyst and the alkyne is converted to alkene and similarly alkene into alkene. Electrophilic addition of halogen acid to alkynes. HCl addition to symmetrical internal alkyne. Hydrogen bromide addition to asymmetrical internal alkyne. In case of mechanism, the hydrogen halide halogens have negatively charged, so partially negative charge, and hydrogen is partially positively charged. Alkyne have electron density higher, so attracts hydrogen, and vinyl cation is formed. The vinyl cation abstracts the halide anion, alloalkene, and again attacks another halogen halides and forms geminal dihalides. Addition of first equivalent. Electrophilic addition of halogen to alkynes. In case of mechanism, the alkyne is attacked by bromine molecules and forms brominium ion. And dihaloalkane again attacked by bromine and produces tetrahaloalkane. In this case, the mechanism is similar. The chlorine have highly electronegative and triple bond, the alkyne have electron density higher. So attack to chlorine, and again the water molecule attacks and produces plus positively charged oxygen on the attached water hydronium, so deprotonation and produces enol, which is the ketotautomerization, addition of water, hydration of alkynes, case of mechanism. The hydronium ion attracts by alkyne and formation of more substituted carbocation. The positively charged carbon is attacked by water molecule, and again lose of hydrogen and produces enol. Again tautomerization, deprotonation, and produce propanone. Alkyne ozonolysis mechanism. Alkyne ozonoid compounds, diketone. Formation of metal acetylides, a hydrogen from atom attached to triply bonded carbon atom is acidic in nature. The acetylene and alkyne on treatment with reactive metal like lithium, sodium, or potassium evolve hydrogen and acetylides. Acidity of alkynes or hydrogen atoms attached to triply bonded carbon atom is acidic in nature. The hydrogen of alkyne is acidic due to sp hybridization of carbon. Higher the s character increase the electronegativity of carbon. It means that electrons from Cs bonds are shifted towards carbon, making acidic. Ethyne reacts with sodium, sodium it halide, sodium acetylide. Acetylene, sodium acetylide, sodium acetylide, disodium acetylide. Okay, it's all about alkyne. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you.